students. So we will start with a fresh topic in data structure today, and that is linked list. Okay. So as the name suggests, it is a list. So it is a kind of data structure which is a type of list. Okay. So why linked list? Because it somewhat looks like this. So now you may ask me, what is this? This is how we describe pictorially a linked list. So linked list consists of nodes. So this thing is one node. This is node 1. This is node 2. This is node 3. Node 4. Now we may add more node as well. Doesn't it look like a list structure which is linked? So you can think of linked list like a rail dabba, okay? Where a node defines the rail dabba and the entire train is a linked list, we can say, in which one bogie is connected to another bogie, isn't it? So here bogie is analogous to a node. So we define a node in a linked list as two parts. So node has two parts. Suppose this is a node. It has two parts. First part is address part. First part is data part. First part is data part, where we store the data, and second part is the address part. Now you may ask me, what is data part, what is address part? Node is a structure which has two parts. See, structure can store different types of data type. You know this very well till now. Okay, so structure can store different type of data type. Here we can store data in any type. It may be a character data, it may be a integer data. Okay, so it can be any type, and the address part points to the next node. That means it is a pointer which has the address of the next node. Suppose this node is stored in address 2000. This node is stored in address 1000. This is at 3000. Suppose I'm just taking randomly, and you may think that node has, suppose data is 8. We are storing integer data, suppose. Then the address is pointing. What is the node pointing to? Node 1 is pointing to node 2, right? So node 2 has address 2000. Then 2000 will be stored here. Okay, I hope you got the idea that what do you mean by the address part. The address part stores the address of the node it points to. The address part stores the address of the node it points to. So the node 1 points to node 2, so it stores the address of 2000. Similarly, suppose the data here is 10, then what is the address part? It is pointing to 3000, isn't it? So it will store address 3000. Similarly, suppose this is 4000 address, then this is suppose having 15 data and it is pointing to address 4000, and this is suppose not pointing to anything. That means it points to null. Null is defined by a slash sign here. So it is the last node. The node in which the address part is null is the last node. Node in which the address part is null is the last node. So suppose the data is 80. So this is the last node. Node 4 is the last node. Why I am saying this, that this is the last node? Because it has the address part null. It is pointing to null. That means it doesn't point to anything else. It doesn't point to a different node. It points to null. So it has nothing. So it is the end. Okay. So this is the last node. So this is how a linked list looks like. Now you may ask, ma'am, how to access this? You can access this through a head. See, head is a pointer which stores the address of the first node. Okay, so what is the address of first node? 1000. So through 1000 we can access linked list. So first of all, access part we will discuss later. And this is an introduction class to linked list. So basically, linked list is a list of nodes which are connected via what? Through address. Because a node has two parts. One is data part and another one is address part. Through this address part, we can link to another node. Similarly, that node can link to another node through the address part. And this way we create a linked list. Okay, that's why it is a list which is linked list. Now, the general properties of a list is that we always access list one by one. List means there is number 1, number 2, number 3, isn't it? We write a numbered list, or we, even if it is unnumbered, still we have something in the first, then we have second, then we have third. That's what we call a list is. Similarly, so accessing a list is in an ordered way. That is, first we will access this, then we will access this, then we will access this node, then we will so and forth it continues. So that's why we call it a list, because it is accessed one by one. Second, all these nodes are linked. That's why we call it a linked list. So I hope I have given justification to this name by explaining you why it is called a linked list. Okay. So now linked list can be accessed through head. Head is the pointer which points to the first node of the linked list. Head is a pointer which points to the first node of the linked list. Okay. So head is a pointer. As you know, pointer stores an address to which it points. So the address of the first node is 1000. That's why head always stores the address of the first node. Head always stores the address of the first node. Okay, so this is how pretty much a linked list looks like. So now we will formally define the structure of a node. Okay, and we will see further how they are linked and how to write an entire program to create a linked list. So first of all, we will define the building block of linked list, that is the node. How to define a node? Okay. So a node looks like this. Struct. We can name it a node. Struct node. And what does the node contain? It may contain a data type. So integer data type, let's take int data. Okay. And a different pointer that stores the address part. So we have data part and we have a integer pointer int star. We can say address, or we can say next, node next, node next, which points to the next node. So node next is a pointer which stores the address of the next node. Okay, so we can define linked list like this. So now we can create a node, struct capital node, and I will define a node as node small a. Okay, so struct node star node. So this is a pointer. Because node is a pointer, it has a pointer data type. The return type is structure because it is a structure type. Okay, so we will define a struct node. To make you see clearly, it's very difficult. Struct node. So this is the return type and node. So we can create a node. So the node will have what? So the moment we declare this, a node will be created. Although memory will not be allocated. For allocating memory, we have to call a function called malloc. To allocate, this is just declaration. So how to allocate memory? We can say equal to struct memory, struct node. Sorry, because we want to create a node. So this is the return type and function is malloc. Malloc means we have to allocate the space for the node. So for calling malloc, we will write star struct node and we will give the size of. You can simply say size of struct. I'm just writing star node is equal to struct node return type malloc size of okay. So size of node we have to allocate. Okay. So this is what we call. Okay. So this is what we call in order to there won't be double tap, it will be single tap. Okay. So this is what we have to call. We have to call the malloc function. Malloc function is responsible for allocating memory dynamically to a to a particular node. Okay. Since we are dealing with addresses, memory can be of different. As I showed you in the example that one node may be 2000, another node may be 3000, it may not be linearly stored. Unlike array, in array what we store? We store linearly, isn't it? One after the another. The slots are one after. If one is stored, if index 1 is stored at 1000, index 2 will be stored at the next integer point, that is 1002, then 1004, then 1008, like this. But here it can be stored anywhere because they are linked through addresses. That's why we have to use a function called malloc. So in malloc function, what we give, we give the size of node, and the node define what is the size here. Suppose this is 2 byte and this is 4 byte. So 6 byte size of node is what? 6 byte. So 6 byte will be allocated to this our node. We are allocating 6 byte to our node, that is the node that we created, which is of type what? Struct node. So this way we declare a node first, the structure, we define the structure, then we allocate or initialize space to it. After that we can initialize the member variables, that is we can initialize what to give to data, what to give to node next. So suppose I can write next here, after giving space I can write how to give space, sorry, how to give data. I can write node data is equal to, suppose I want to store 15 that one. So the moment space is allocated, this is created. A node is created. A node will be created. Now you have to write like this: node arrow data is equal to 15. That means node का data वाला part में 15 will be stored. So what will be stored here? 15. This is node which is created after calling malloc. After this malloc, we created this. Now we are assigning 15 to node data. So node data part will be 15. So this will be 15. Now we have to give the address. So what we will give? Node. Suppose this is a singular node. It is not pointing to any address. Then what we will give? Node next. Node next is equal to null. If we give null, then null will be allocated to this node. So the node is created and it looks like this. Okay. So you simply write, because it's not a string, you can simply write null. Okay. So node next is null. That means we successfully created a node of a linked list. It is not linked now. Why it is not linked? For linking, we need to create another node, and we have to update the address part. That is, we have to update node next equal to address of that node. Okay. So we will do that complex part later. We will see how to create an entire linked list. But since we have to create node one by one, we better do it in a function. Okay, we will write the creation process of a node in a function, and we can simply call that function again and again when and as we want to create a node. Okay, so this is what happens with, this is what a linked list is, and this is how we define the structure of a linked list, and this is how we allocate space to the linked list, and this is how we initialize the member variable of a linked list. Okay, so I hope it is clear. You have got an overall idea of what a linked list look like, what it consists of, how to define the structure of a linked list, and how to allocate space and initialize it member variable. Okay, so we will continue in the next class with how to create an entire list. I will write the code and walk you through it. Okay, meanwhile, if you have any doubt, you can post your doubts in the comment section.